Um, Hi, I'm Irin Kim. I'm a UX designer on the Google Fonts team. Thanks for coming today for our talk about Google Fonts Korean and Japanese support, which is happening at the auditorium in the AP school that is located in Antwerp. So we are in Antwerp right now. Let's zoom out a little bit more. A little bit more and past North America and go to west across the Pacific Ocean and we get to East Asia. As you can see here, Korea is located in East Asia between Japan on the right side and China on the left side. The Korean peninsula has been a very crucial point in geopolitical context, both politically and economically. So people who live on the peninsula use Hangul to write the Korean language, and it's the official writing system. So let's zoom a little bit in to see how Koreans use Hangul in their life. Oops, this is too far north. So let me zoom out quickly. It's a little bit sensitive thing, so and go to south again. Here we go. If you have a chance to visit Seoul in South Korea, you'll start to see Hangul on the road signs as you arrive. Also on the street. By the way, this was the first Starbucks store with non-Latin sign in the world. You also see Hangul posters on the walls or in a movie poster. And if you're a fan of K-pop, you might have already seen beautiful Hangul types on album covers like this or like this. More and more brands and companies in Korea started to work on brand type for their product, such as 배달의 민족. Hangul typography played a very important role in a huge political issue last year when the president was impeached. Protests occurred almost for 5 months. The Hangul typography the protesters used in their poster, as you can see here, helped spread their message to South Koreans. Also, you can find Hangul in banknotes. There are 4 different Korean bills, and people see the faces in the bills pretty much every day. The people in the bills must be important in Korean history, but this person in the bill is the most important people for us today. He is King Sejong the Great, the 4th king of the Joseon dynasty, and he developed Hangul. In 3 years, from 1443 to 1446, which I think it's amazing because 3 years is like the time to finish a PhD, and he finished creating a script or writing system as his thesis. I guess he was a workaholic. Before he created Hangul, Korean used Chinese characters for writing, but not all Koreans could write with Chinese characters because of the fundamental differences between 2 languages and its massive number of characters. Very few people, usually just a high-class, well-educated, used it. So many lower-class people were illiterate because of this, and King Sejong wanted to fix this problem. So he developed Hangul to help people with little education more easily learn to read and write. And he introduced his writing system in 1446 with the publication of Hunminjeongeum, which means explanations and examples of correct sounds for the instruction of the people. When Hangul was created, consonants were designed based on articulatory phonetics. So the anatomy of the letters shows the speech organs. Hangul is the only script that does this. Additionally, the shape of the vowels are based on the fundamentals of yin and yang. So they represent the heaven, the upright human, and the flat earth. The letters in the Korean alphabet are called jamo. Jamo started with the 5 consonants and 3 vowels from the previous slide and developed it into 19 consonants, as you can see here, and 21 vowels. In Jamo, consonants and vowels are grouped into syllabic blocks. Each block consists of up to 3 parts, which are 초성, 중성, and 종성. 초성 is a consonant, or sometimes a double consonant, and is called the initial. Vowels are medial, and the final is one or more consonants at the bottom or the end of the syllable. And as you can see here, the visual balance of a jamo changes in relation to its surrounding jamo, and this is why a Korean font usually includes every possible combination of jamo, resulting in 11,172 characters, which is a lot. With the combinations of jamo, a word can be created with one or more syllabic blocks. So here, the first word means I, and the second word with 2 syllables is school, and the third one is go. And a sentence can be created by arranging words into right places grammatically. So this sentence means I go to school. After King Sejong created Hangul, both Hangul and Chinese characters had used for a while. And finally, in 1849, Hangul became an official script in Korea. Hangul became more widespread, and the first newspaper, 독립신문, was written solely in Korean alphabets without any Chinese characters. From 1910 to 1945, Korea was under Japanese rule. During this time, there was a newspaper law that banned the publication of local newspapers. The law was relaxed in 1920, and Korean newspapers such as 조선일보, 동아일보 were founded and began publishing. During this time, there was limited Hangul typography development. However, Kyungho Park did amazing work on type design. He also created the principles of Hangul typography for the vertical writing system, and he developed the geometric Myeongjo style by revising 궁체, which is a Korean traditional calligraphy style. Korea gained its independence at the end of World War II. With the political and cultural influence of Western countries, horizontal writing was adopted and started to be used for elementary school textbooks. Horizontal writing is now the primary style within Korea. Hangul typography was driven by printing, the publication of books and newspapers. During the Korean War, resources were scarce and printing nearly ceased. And amazingly, there were still great type designers who had furthered Hangul typography in these poor environments. Type designers are always strong. Yes. After the war, the first phototypesetter was imported into Korea. With adoption of this new technology, Korean type designers actively started to produce Hangul typefaces. So Jung Ho Choi was a prolific typeface designer, designing around 30 typefaces. Latin typefaces can be serif or sans serif. In Korean fonts, the Myeongjo style is similar to serif, and the Gothic style is similar to sans serif. Jung Ho Choi was also responsible for establishing highly legible Myeongjo and Gothic styles in digital typeface. In 1955, the 동아일보 publication adopted the Benton matrix cutting machine and commissioned the typeface to Jung Ho Choi. He finished a high-quality typeface called 동아 publication in 1 year, and it was used in new encyclopedias and books. Byung-woo was originally an eye doctor, which is really interesting to me. And he developed the Hangul keyboard systems to speed up the publication process for his medical education. First, he created a 2-set Korean keyboard system, and later, a 3-set Korean keyboard system that closely matches the Hangul construction of an initial, a middle, and a final. So his 3-set Hangul input system divided the keyboard into initial, middle, and final positions. So the right green part is for the initial, which is for the first letter of a syllable, and the brown for the middle, and the red for the final. With the economic development project of South Korea in 1960s, the Korean type foundry in South Korea started to grow. The first Korean type foundry was Sandol, which was founded by Kumosok in 1984. He was disappointed that most Hangul typefaces were produced in Japan, and he started a type foundry to produce Hangul typefaces in Korea. From 1989 on, the availability of Macintosh computers and various design tools have enabled the creation of many more Hangul digital fonts, and this led to emergence of many more font foundries in Korea, such as Yoon Design, Jigjisoft, Fontrix, and Yangjang Type Foundry. With Hangul mechanization and appearance of type foundries, Korean coded character set standard has been developed as well for 11,172 characters. And because of this large amount of characters, the price of designing a font is very expensive and takes a long time. So there haven't been a lot of open source fonts available in Korea. And the Google Fonts team, Google Fonts engineering team developed a great technology that serves Korean fonts quickly. With this new technology, we wanted to support Korean as much as possible. So Soo-young Jang, who is one of type designers of the Yangjang Type Foundry, and I contacted most of the Korean type foundries, and we now have 25 Korean fonts available on Google Fonts. I'd like to thank you to the all type foundries. And on Google Fonts Korean mini sites, you can play around with the new Korean fonts by applying different tools to the font, which shows the possibility and the potential of the using Hangul fonts on the web. You might want to know how Korean fonts can be so fast on the web, and I'll toss it to Evan for more information.
Thank you, Irin. I just have to say, wow. I'm a native English speaker, and I have to deal with 26 letters. Seems like Irin's situation is much more complex. I'm also fascinated by a society that can change from a vertical writing system to a horizontal writing system. That seems on par with changing which side of the road you drive on. And that's a hint to my British friends. Okay, so I'm Evan Evans. I'm a software engineer on Google Fonts. There's a lot of type designers, many here at ATypI, that are designing great typefaces. One of the goals of Google Fonts is to ensure that those typefaces can be used without slowing things down. So more simply, we want to deliver fonts fast. Google Fonts was launched 8 years ago. Fast is important. Did I mention that? Fast is important. But so is easy to use. We don't want barriers to adoption, and we also want to provide fonts for everyone. Until now, we've done a decent job of providing fonts for everyone, but CJK has been a very difficult part. So I'm here to share with how we have recently shipped Korean and Japanese fonts and share with you what we did to make that possible. This is a quick overview of the existing technologies that are being used for delivering fonts fast. I'll go through each one in just a bit more detail. Broadly is a terrific data compressor. Think of it as beefed up gzip or gzip on steroids. But if you leave here with only remembering one word about Broadly, just remember it's good. It was developed at Google in our Zurich office by some very smart people. It achieves better compression than gzip, takes the same amount of time to decompress. The compression time is a bit longer, but we do all that ahead of time on servers, so we don't care. WAF2 is the Web Open File Format version 2, and it rewrites the font file to make things smaller. It uses Broadly. The graph here shows the sizes for Nanum Gothic, one of our Korean fonts. The raw size is 4.2 megabytes, much too large to download onto a web page. WAF reduces that to 2.3. That's a very good reduction. And WAF2 reduces it further to 1.7 megabytes. That's an extremely good accomplishment, but it's still way too big. 1.7 megabytes is still way, way too big. Subsetting is a concept where we take a font and we chop it into pieces. We do this along languages or script. So like if you have a Greek page, it may not need the Vietnamese characters. And a Vietnamese page may not need the Cyrillic characters. Additionally, keeping a script together prevents us from breaking any OpenType features. Unicode range lets the browser choose which pieces to download. This is a simplified example showing the CSS that's returned via the Fonts API. You don't have to type this, we return it to you. What this is telling you is if your page uses anything in this Unicode range, in this example from 400 to 45F, that's in the Cyrillic range, then it's going to download the Cyrillic.waf2 file. Likewise for Latin, if you use anything in Latin range, which is 00 to FF, we're going to download the Latin file. And the final piece of technology is the browsers and their caching. They cache the font files that they download. So if you go to visit website A and you download the file, then the font file, then when you visit website B, if it needs it, it's already there. It's instant, there's no delay whatsoever. So if you bring this all together, Unicode range and subsetting let us transfer only a portion of the font, sometimes a significantly smaller portion of the font. WAF2 and Brotli take the portion we're delivering, make it much smaller, and then the browser remembers what it gets and reuses it. And all of this is very effective for the Latin scripts, for Cyrillic, for Greek, for Arabic, for the Indic languages, but not so good for CJK. All this excellent work is just not good enough for CJK. You've seen a couple more presentations here and have gotten the point across. Very large code point size. I don't know about you, 70,000 I saw in an earlier talk today. That was a frightening number. We define Korean at 17.4 code points and Japanese at 16.5. Additionally, the individual characters are much more complex. So there's a double-edged sword here. So to repeat, Nano Gothic 4.2 raw, 1.7 WAF2, 40% of the original, not good enough. Here's an example just of a comparison. A Latin uppercase R, you see the form, and this is, on the right-hand side, is a Korean syllable that is frequently used in the word sunny, like a sunny day. So it's got 4 pieces, more complexity. To demonstrate a little bit more, here's what you see in glyphs. The uppercase R has 52 control points, and the sunny syllable has 147. There's almost a 3x multiplier there. In the words of the famous philosopher Yoda, control points lead to size. Size leads to slowness. Slowness leads to suffering. So, we were able to launch Korean fonts. We now have 25 of them. We're very, very happy to announce this. So we chose to do Korean first, and the question is, how did we do it? We took the idea of creating subsets, and we applied this approach recursively. We're software people. We do that sort of thing. So we chop the Korean fonts into smaller subsets and tell the browsers about the ranges, and then the browsers pull over what they need. All of that sounds well and good, but we have over 17,000 characters, and there are zillions of ways to chop them into subsets. So which ways to use? We decided to take a little bit look at some data. We looked at a Korean news site. It had over 50,000 total characters, but only 729 were unique. Like, okay, there's a real propensity to use a small number of characters a lot of times. We looked at a YouTube video and its comments, under 2,000 characters on the page, under 400 unique ones, and it only added 5 more unique ones to the news site. So then we decided, okay, let's look at this in more detail. We're at Google, we have access to millions of web pages. We looked at them, the Korean web pages, and we get this graph of frequency. Very steep graph, a hockey stick graph, as some people will call it. it's very tempting to look at this graph and say, look at that, it comes down at about 25,000, the graph hits the bottom. Why don't you just chop it off at 2,500? Why don't you just chop it off at 2,500 and be done with it? Solve your problem right there. Well, the long tail is used. That doesn't work. You get a very poor user experience if you do that. So what we chose to do was 3 experiments. First one is we just sorted everything by code point. We created 100 subsets, equal size, cut by code point, boom, 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 boom. So we call that the code point sort. Then we took the sort of opposites, said let's sort by frequency. Let's look at that graph. And since we know the most frequent ones are being used a lot, let's put a bunch of them together. So we arbitrarily chose 2,000 in the biggest bucket, and then the next 1,000 in the second bucket, and everything else, another 98 subsets. And then we did a hybrid of the two. Do the high frequency stuff, the 2,000, 1,000, and then do everything else with code point. So if we look at the results, in this graph, a bigger number is better. This is how much percent was saved. The code point sort saved 71% of the data. That's very impressive. Frequency did even better at 86%, and hybrid sort came in at 88, which was the best. The primary difference between frequency and hybrid sort here was the CSS is smaller in the hybrid sort because of the code points being in order for the low frequency. So 88% reduction allowed us to ship Korean. We were thrilled with that. We're also not satisfied. Yeah, that was the first round of tests. We got a huge win, but we believe we can do better and we can do more. So, ready? We're going to go do the next round of tests. Just a quick catch-up. Here's what the hybrid sort looks like. Subset 1, 2,000 most frequent. Subset 2, the 1,000 most frequent after that. Then everything else by Unicode value. That's what we're doing. And we have these questions. Is 3,000 the right place to have that line? Is it too many? Is it too few? We don't know. We also have a difference here with the HTTP1 versus HTTP2 protocol. HTTP1, we were worried about the total number of files you would download because there were browser limits on how many files you could download from the site simultaneously. There were small limits, like 4 and 8. HTTP2 makes those limits go away. They become like 100, that sort of thing. We also realized that doing the low frequency characters like code point was a good idea. We got much smaller CSS, so we wanted to retain that. So the next batch of experiments are just the high frequency boundary. We're going to try 1,000 and 2,000, as well as continue the 3,000. And we're going to more aggressively subset the high frequency code points, use 10 and 20 rather than 2. And a reminder, the baseline here is the hybrid sort. Give you a quick spoiler alert. Everything we did improved. We anywhere from 29 to 38%. So here's the 3,000. Kept the high frequency line at the same place at 3,000. We ran experiments with 10 and 20 subsets. 10 subset came at 29%, 20 at 34. The conclusion here was more subsets was better. And we tried 1,000, put the line at the 1,000 line. Results here are a bit better than at 3,000, and we get the same relationship that more high-frequency subsets performs better. Okay, then we go to 2,000, we get the big star here because this was the winner. Once again, more high-frequency subsets perform better, and we had a total of 38%. This is 38% of the remaining, and so that was the winner, and that's what we shipped. And here's a look at everything together. The green ones are all the ones with 20 subsets. Every single 20 subset approach outperformed every single 10 subset approach. There's information there. You also notice on the left-hand column that it always goes in 2,000, 1,000, 3,000. There's information in that as well. So combining rounds 1 and 2, we're now saving around 93%. As I said, 20 subsets is always better. The high frequency line, 2,000 was the best, and we think the even better one is somewhere between 1,000 and 2,000. That's what the data. Okay, so here's what's happening with Korean adoption. We had an early access program, and then we announced, boom, graph going up. If you go to our website, fonts.google.com, you'll see this about Nanum Gothic, 31 391 million served last week. And this is also a breakdown of country. Korea with 87%, the US is 1%, everybody else combined into 12, where you see Japan, China, Vietnam, that you would expect in the others. Canada was in there. The first time I looked at this, I was really, really pleased because Belgium was in the list. That's perfect for ATypI and Antwerp. So we're going to apply the same thing to Japanese. We look at the character counts, run some similar tests. Spoiler alert, we reduced by 83%. And we managed to ship Japanese. We now have 8 Japanese fonts available. Here's just what the graph of Japanese characters look like. You look at this and go, hey, it looks like the same graph we had with Korean. And it does, basically. But if you look more closely, there's a difference. Japanese has more high-frequency characters than Korean. So this changes things. This changes how you want to divide things up. So we shipped the Japanese, and we ended up with the test coming out with the 3,000 line being a tiny bit better than 2,000 line. That was one of the differences. And we got to 83%. We didn't get to the 93% that Korean got because of more characters being used. You have to deliver more data. So what's next? We're going to continue to run some more experiments, change the high frequency line, experiment more with whether or not we're going to have a big high frequency bucket. We believe that's going to have a big win. We're running these experiments right now. We haven't collected the data, but they're in the field right now. Obviously, we need to support Chinese. We're talking about CJK, and I've only talked about K and J. Those are on the list. And C has 2 forms. So there's 2 things to do there, simplified and traditional. Longer term is incremental transfer, where you don't break it into separate files, but you deliver a base file, and then you deliver deltas, and the browsers build up the file. So this is an example of what an incremental transfer would look like. You go to the first page and you get yourself a little bit of base of that font file. You go to the next page, you get some more. And next page, you get some more, and you get some more. And after a while, this becomes kind of fun playing the game, and it seems like it's ready to level up. Whoops, I went too far. Okay. That was basically a recap of how we deliver fonts fast for Korean and Japanese. And I gave it away, but boom, deliver fonts fast.